Hey, topic of math and history, and we're going to be learning about graphing a quadratic with x squared. So, we have been in the past been looking a lot with y equals x stuff, like y equals 3x plus 7. Or we can call it in its y equals mx plus b form. Or we could also call it slope-intercept form. We've been seeing a lot of this, that, and when you do that on a graph, you usually see a line that is linear on a graph. Let's try and graph this and see the linear line. That is definitely linear, alright. That is when you have the formula y equals mx plus b. But sometimes you will see stuff on graphs that are not perfectly linear. Sometimes you will have to be creative and you'll see something like this. Y equals x squared. With y equals x squared, instead of a linear line, this is called a quadratic because we are using the number 2 as an exponent. And not just any kind of line on a graph. Instead of a straight linear line, it's more of a curved line, something that looks like this. Let's try and graph it. To make this more interesting, let's see Super Mario explain what this kind of shape is, and we'll find out what it is. So what kind of line did Mario make? Yes, this U-shaped line is called a parabola. A parabola is not a linear line. It is a curved line, and the equation itself is pretty different and pretty cool because this one's using an exponent of 2. So with y equals x squared, what we're going to be doing is making a ratio table, and we'll understand what kind of powers it has because we have our x value and a y value. So here's y equals x squared. Let's put some numbers in. So if we insert 3 in for x, 3 squared is going to be 9. But wait, negative 3 squared is also going to equal 9. So we have to make another x. Negative 3. Let's try another one. Let's use 5 because that's one of my favorite numbers. 5 squared is going to be 25. But that also means negative 5 because a negative times a negative is a positive. Just like a positive times a positive is also a positive. So let's add one more number. Let's add 10. So 10 squared, 10 times 10 is 100. So we put 100 right there. But a negative 10. So what we're gonna do is the numbers that we came up for to try and figure out an experiment with y equals x squared, we are going to put them onto the graph and see y is a parabola and why we have 2 x's. Let's graph it. So what we just saw there is we had 2 points on a graph on the opposite side of each other, and we made a U connecting the two. So basically, a parabola, or y equals x squared, actually allows you to have two x's that will become a y. We have a negative times a negative, and a positive times a positive. And when you graph them on the graph, you get 2 points on the graph that make the u and still get to your y accurately. That is very different than a linear equation, because a linear equation only goes one direction. It goes up as a positive or down as a negative, but it only allows you to have only one input and one output. With the parabola, you're allowed to have 2 inputs and 1 output, so you can get creative however you want. Let's see this as an example in Super Mario Bros. But the red coins that you saw earlier is going to represent -3, 3, and 9 as a coordinate.
Let's go!
So that is how you can be very creative with a parabola. Many people in my class was actually arguing about whether a parabola is a slope. So a parabola is a curved line, which we said earlier in the video. Some people say that this is a slope, but when they think of slope, they usually think of this, or slope-intercept form. But the problem is, since this is a slope, this cannot be defined as a slope, or a linear slope, because it is not a straight line, and it's not going up or down. It's going down and up. But if you think logically about the parabola, if you are in calculus right now, or if you want to learn about calculus, some people think that a parabola has an infinite amount of linear slopes whenever you move within the line. Here's an example. If I have a line right here, and if I want to move it around the parabola, the slope changes depending on when I'm at the parabola or where I'm at the parabola. So you can have an infinite number of linear slopes in a curved line when you're studying calculus. This is pretty cool. So if you are in calculus right now and your friends are arguing about a parabola being a slope, you should tell them that it's not really a linear slope, but it can have infinitely amount of slopes every time you move on the curved line. Here's an example. Imagine you're holding a really long metal pole. Then, when you try and run around with it, you accidentally hit someone by swinging it because it's a linear slope, but you go up ending in a curve. So you accidentally swing it at someone. It hits them. Hopefully they don't get hurt, but you're using mathematics in calculus because you're trying to experiment that a curved line or a curved turn has infinitely amount of linear slopes. Here's an example.
He's escaping.
And that is an example of the parabola having an infinite amount of slopes. And that is also how we can understand how to graph a quadratic with x squared. I hope this video has helped you. Thank you for watching Tao Ping Life's Math Industry. Like and subscribe!